Hello and welcome to helpyourmath.com. In this video, we are going to talk about the solutions to linear equations in two variables. A solution to a linear equation in two variables will be an ordered pair that makes a true statement. A true statement would be something like 5 equals 5 or -1 equals -1. A false statement would be something like 5 equals -1 or 0 equals 3, because those are, well, not true. We can determine if an ordered pair is a solution of an equation by plugging in the first coordinate for x and the second coordinate for y. Another important note is what exactly is a linear equation. We see linear equations in two variables because they have, well, two variables, and the variables are being raised to the first power. So the two most common forms we might see them in is where y is one variable, y equals m times x, that's x is the second variable, plus b. Or we might see a times x plus b times y equals c, where a, b, and c are all real numbers. And then the first example, m and b are both real numbers. So in either of these two forms or any other variation, the x and the y are the variables, and they're both being raised to the first power. They don't have any radicals. They're not in denominators or anything like that. That's what makes a linear equation. So for our first two examples, we're looking to see in the first one if -2, 8 is a solution of the equation. So this equation is written in that first form, that y equals mx plus b form. And what we do is we're going to replace x with -2 and y with 8. The ordered pairs are always of the form xy, so we don't get to pick and choose which variable we plug into. X is the first one, y is the second one. And then when we're solving this, so first of all, the answer is going to be yes or no, because it's saying, is this true? And either yes it is or no it's not. When we're setting this up, because we don't know if it's going to make a true statement and we don't want to have something false here, we put a question mark over the equal sign. Does 8 equal, and then what am I plugging in? 2 times -2 minus 4. Then we would want to clean up both sides and see if they match. Now I don't have to do anything on the left side, it equals 8. On the right side, 2 times -2 is -4, and -4 minus 4 is -8. So now the question is, does 8 equal -8? No, it does not. Those are opposites. That's not the same number. So the answer is no. In the second example, are either -3, 0 or 7, -1 a solution of the equation 3x minus 2y equals 19? Pause the video and see what you get. Are they both? Is it yes, yes? Is it yes, no, no, yes, or no, no? Okay, how'd you do? Were you a little disappointed? That's okay. Let's see. So again, we're going to replace -3 for x and substitute in 0 for y. And we're going to see if this makes a true statement or not. So that's 3, that's given, times -3 minus 2 times 0. Does this equal 19? 3 times -3 is -9. 0 times 2 is 0. -9 minus 0 is -9, which does not equal 19. So this is another no. No, -3, 0 is not a solution. How about 7, -1? We plug in 7 for x, -1 for y. How about 3 times 7 minus 2 times -1? Does that equal 19? Let's see. So 3 times 7 is 21. A negative times a negative is positive. 2 times 1 is 2. Well, this makes 23. Oh, it was looking so promising. However, 23 doesn't equal 19, and we have yet another no. So nothing worked out on this page. We were so close, though. If I had asked, is 7-1 a solution, then we would have had our first yes. But I didn't, so we don't. An equation in two variables has an infinite number of solutions, right? So there's an infinite number, although we didn't see any, there's an infinite number of combinations of x's and y's that would make a linear equation true. We can be given one coordinate and asked to find the other, as we will see in the next example. Let's take a look. Okay, so this time we're given the linear equation, just like we were in the previous example. But this time I'm saying, okay, I want to know, give me the yeses. I saw enough no's. Now let's actually see some solutions. So now I'm giving you, in this case, in this first one, a y coordinate, and I want to know what's the corresponding x. And then in the second two, I give you the x coordinates, and I want to know what the corresponding y values are. So let's start with the x, 2. What we're going to do here is we're going to not do anything to x, right? Because I would be replacing x with x, which is doing nothing. And I'm going to replace 2 for y. So this would give us 2 times x minus 3 times 2 equals 24. And now what I want to do is I want to get x by itself so I can see what value of x corresponds to y equals 2. First I need to multiply though. I have 3 times 2, which is 6. And now I want to isolate the term containing x. So since it's being subtracted by 6, I'll add 6 to both sides. And now I get 2x equals 30. That's 2 times x. To undo a multiplication, I will divide both sides by 2, and we get x equals 15. So now I know this first ordered pair is 15, 2. And just so we can see what a yes does look like, let's and to double check our work, let's actually verify that 15, 2 does produce a true statement. So this would be 2 times 15 minus 3 times 2. Does that really equal 24? Well, 2 times 15 is 30, and 3 times 2 is 6. So we get 30 minus 6. Yep, that equals 24. So this would be a true statement. We get 24 equals 24. Hooray. Pause the video, see what you get for these y values when I give you some x values. All right, how'd you do for the first one? Let's find out. Did you check your work too? You didn't? Why not? All right. So we have the same equation. We're looking at 2x minus 3y equals 24. And this time we're looking for 6, y. So I'm going to replace x with 6. So we get 2 times 6 minus 3 times our unknown, what we're going to figure out, equals 24. That's 12 minus 3y equals 24. So now I want to isolate the term containing y. There's a 12 being added, so I'll take away 12 from both sides. And I get negative 3y equals positive 12. This is being multiplied, right? This is negative 3 times y. So I'll divide both sides by negative 3. And I end up with y equals positive divided by negative is negative. 12 divided by 3 is 4. And there we have it. So this time the ordered pair would be 6, negative 4. This would also make a true statement if I were to check my work. And lastly, we have this 0, y. So I have 2x minus 3y equals 24. And now I'm curious, if I plug in 0 for x, what's the corresponding y value? Well, let's see. So we have 2 times 0 minus 3 times y equals 24. 2 times 0 is 0. 0 minus 3y. Oh, well, that's just negative 3y. And then, since that's being multiplied, right, that's negative 3 times y. To get y by itself, I would divide both sides by negative 3. Negative divided by negative gives me positive y. Positive divided by negative gives me negative 8. And there we have it. If I plug in 0 for x, I end up with a y of negative 8. How'd you do with those y's? Awesome? Okay, here's my sidebar nation. Since we cannot list all the solutions of a linear equation, right, so we found 3 of them here. We have 3 ordered pairs that do in fact make a true statement, but that's not all of them. There are infinitely many. We represent all of the solutions by making a graph with the solutions we find. If we're talking about linear equations in 2 variables, the solution set will form a straight line. This is also a nice way to double check your work, because if you end up with a triangle, well, that's not going to be a straight line. Something went wrong. I would double check your work. So just to look at these, if we were to graph these, now I know these are going to be a little bit tough to graph, especially the 15-2, but they should form a straight line. So I'm going to do the best I can here. Let's see, draw my axes. 15 is x, and then I need to go down to negative 8 over 6. Okay, so I don't have any negative x's, so I'm going to really just... And again, this won't be perfect because you can already tell my grid is not going to be perfect. But let's just see if these do form a straight line. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then I need to go up 2. 15 up 2 would be right here. Next, we have 6, negative 4. Put some negatives on here. I think I need 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. 6, 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4. And lastly, 0, negative 8. So that would be down here. So my graph might not be perfect, but you can tell if we were to connect these 3 points, it's going to be roughly a straight line. If I used a more perfect grid, it would probably turn out more perfect. That kind of worked. That wasn't so bad. So we can see, okay, I feel pretty good because at least I got a straight line, right? In our last example, now we're also going to graph the line along with creating the table of values. So one option when you're asked to graph is to create a table of values. Here I actually give you some values to use. Sometimes you have to just create it and make up your own x values or y values. But we're going to use this table accordingly. So first it says plug in 0 for x. So that would be 0 equals, sorry, that is not 0 equals. That is going to be 0 minus 2y equals negative 4. And now I want to figure out the corresponding y value. So let's get y by itself. This would just be negative 2y equals negative 4. Divide both sides by negative 2. And we get y equals negative divided by negative is positive. 4 divided by 2 is 2. Okay, so this means we plugged in 0 and we got an output of 2. So that's the corresponding ordered pair is 0, 2, which I'll go ahead and graph. Next up, this one says plug in 0 for y. So here I'm going to say x minus 2 times 0 equals negative 4. 2 times 0 is 0, so I just get x equals negative 4. So I plugged, well, x is negative 4, and I plugged in 0 because that's what it said here. So that would be my next ordered pair. Negative 4, 0 would be right here. Then the third one says plug in negative 1 for y. So that's the next thing I want to do. I'm going to say x minus 2 times negative 1 equals negative 4. Negative 2 times negative 1 is positive 2. And now to get x by itself, I'll take away 2 from both sides. So I get x equals negative 6. So x is negative 6 for the y that I plugged in, negative 1. This one's going to be off my graph a little bit, but that's okay. We'll make it work. So we have negative 4, negative 5, negative 6, and then negative 1 would be down here. Do these 3 points kind of look like they're making a straight line? Are they forming a straight line? Yes, if I was to try to connect them, I would connect them with a straight line. Absolutely. So far, so good. And our last point, we're going to plug in negative 3 for x. So I'm going to go over here because I'm running out of space. And I'm going to say negative 3 minus 2 times y equals negative 4. So I'm plugging in for the variable in which it's located in that column. Let's see, I want to isolate my y term, so I'm going to add 3 to both sides. Over here I get negative 2y, and here I have negative 4 plus 3 is negative 1. This is negative 2 times y, so I'm going to divide both sides by negative 2. And we end up with y equals negative divided by negative is positive, and 1 divided by 2 I'm just going to leave as 1/2. So this one's not as great. I plugged in negative 3. I have x is negative 3 and y is 1/2. We'll just have to do the best we can with this. So negative 3, 1, 2, 3, and then 1/2 is just halfway between 0 and 1. Now using a straight edge, or in this case I had to freehand it, does it look like these 4 points form a straight line? It does. And so even though we don't show it, every other point here, so actually that should have been on the graph, but every point that would fall on this line would also be a solution. So that's the infinitely many. So some of them work out really nice, like we saw the first 3 all worked out nice. The fourth one did produce a fraction, and of course there are going to be infinitely many that contain fractions, that contain irrationals, but we can define the line by just 2 of the points. These have been examples of solutions of linear equations in 2 variables. Thank you for stopping by.